If you think that the idea of colonizing other planets is something out of a particularly far-fetched science fiction movie or book, Elon Musk, founder of private space travel company SpaceX, has a surprise for you. Musk has said that there's a 70% chance that he'll travel on a rocket to Mars in his lifetime, and that he's thinking about eventually moving there to live in a human outpost on the surface of the Red Planet. Unlike the protagonist of the science fiction novel and movie, The Martian, Musk most likely wouldn't be lonely on the Red Planet. Back in 2012, at a conference of the Royal Aeronautical Society in London, he sketched out a vision for a Mars colony that eventually would grow to the size of a small to medium-sized city on Earth, with 80,000 inhabitants. While Musk envisions a private sector Mars colony, NASA has plans to eventually establish a base on Mars as well. The Trump administration currently is focused upon revisiting the moon by 2024 and building a permanent base there that would provide the opportunity for developing the technologies to take American astronauts to Mars and beyond. In anticipation of that day, NASA already is testing technologies such as space habitat modules, basically spacefaring mobile homes that would provide life support for humans living on the surface of other worlds. NASA collaborated with Northrop Grumman to construct the Habitation and Logistics Outpost Module, also known as HALO, for the space agency's lunar outpost, Lunar Gateway. Northrop Grumman won a $935 million contract that includes integrating the said module to the propulsion and power equipment that Maxar Technologies initially provided. The European Space Agency also has envisioned setting up its own moon village on the lunar surface. Meanwhile, visionaries also are looking toward the eventual colonization of Earth-like exoplanets orbiting around other stars. What has humans looking to make new homes in the cosmos? The National Space Society, a private sector organization that promotes a spacefaring future, cites a variety of reasons for building colonies in space. One reason is that other worlds contain vast amounts of metals and other natural resources and potential sources of energy, and provide opportunities for potentially profit-making industries. Establishing outposts on other worlds also might be a way to hedge the bet on humanity's survival, in case our existence on our home planet is threatened by a nuclear war, climate change, pandemics, and population growth. The late physicist Stephen Hawking believed that humanity needs to colonize another planet within the next century, if it is to avoid the threat of extinction. But before humans venture to distant worlds, they'll most likely be starting with a colony on the moon. Lunar living. Ever since the Apollo program put the moon within our reach, establishing a lunar outpost has seemed a logical next step. Earth's natural satellite offers several advantages over more distant destinations, such as Mars or Saturn's moon Titan. First, it's relatively close, which means crews could get back and forth from the Earth and moon in just a few days. Additionally, a lunar base would enable use to learn a lot about the effects of low gravity, isolation, high doses of cosmic radiation, and disrupted circadian rhythms on human space colonists, knowledge that would be invaluable when we eventually venture to other worlds. Additionally, the moon's low gravity and closeness to Earth would make it an ideal location for a spaceport from which astronauts could embark on missions to Mars and worlds even further away. And in terms of long-term possibilities, the moon is a big place. Its surface is roughly the size of Africa, and it has plenty of room for human colonists. But living on the moon won't be any picnic. With no atmosphere, it experiences huge temperature extremes, swinging from minus 298 degrees Fahrenheit at night to 224 degrees Fahrenheit in the daytime at the equator. Its surface is also peppered constantly by micrometeorites and cosmic rays. Then there's the issue of food and water. In 2018, a team of scientists spotted the first definitive evidence of water ice on the lunar surface, a discovery that suggests that future lunar colonists might be able to extract their own supply, which could provide water for drinking and for irrigating plants in lunar greenhouses, as well as a raw material for rocket fuel. NASA's current plan for returning to the moon involves building a lunar orbital station, the Gateway, which will serve as a staging area for teams of astronauts to make short visits to the lunar surface. Gateway will be humanity's first space station in lunar orbit to support NASA's deep space exploration plans, along with the Space Launch System, SLS rocket, Orion spacecraft, and the Human Landing System, HLS, that will send astronauts to the moon. NASA has focused Gateway development on the first two elements of Gateway, the Power and Propulsion Element, PPPE, and the Habitation and Logistics Outpost, HALO, which will launch together on a commercially procured launch vehicle. In February 2021, NASA selected SpaceX to provide launch services for the integrated PPE and HALO spacecraft. After integration on Earth, PPE and HALO are targeted to launch together no earlier than November 2024 on a Falcon Heavy rocket from Launch Complex 39A at Kennedy. As astronauts prepare for missions to the lunar surface, they will need deliveries of critical pressurized and unpressurized cargo, science experiments, and supplies like sample collection materials. In March 2020, NASA announced SpaceX as the first U.S. commercial provider under the Gateway Logistics Services contract to deliver cargo and other supplies to Gateway. One logistics services delivery is anticipated for each crewed Artemis mission to Gateway. Successful settlement of Mars. Some space experts have argued that NASA should focus on going to Mars instead of returning to the Moon. Since NASA's December 2017 shift to focusing upon returning to the Moon, it hasn't put out any updated plans for making a manned landing on Mars and establishing a human colony. But in a plan that the agency published in 2015, the initial mission would be complex. Astronauts would make the 180-day trip to Mars in a crew habitat module, a two-level container that would double as a habitat on the Martian surface. By the time the astronauts landed, a separate laboratory module, a rover vehicle, and other equipment, including a nuclear reactor, and supplies already would be waiting for them on the Martian surface after being transported there by robotic spacecraft. Another spacecraft, fueled for a return to Earth, would be positioned in orbit to enable the initial crew to eventually return to Earth. Subsequent missions might expand that original base or set up others to form a Mars colony. On Mars, human colonists would have to grow their own food. NASA has been experimenting with growing vegetables on the International Space Station, and also has developed simulated Martian soil, which contains nutrients that plants would need to survive, to better understand how it could be used to grow crops. Over the years, science fiction writers and futurists have speculated about the possibility of terraforming Mars, to transform its environment to something closer to Earth's. One approach would involve releasing carbon dioxide trapped within the Martian surface to make the atmosphere thicker, which also would help to trap solar radiation and warm the surface. However, a NASA study published in 2018 concluded that the Martian surface doesn't contain enough CO2 to be put back into the atmosphere to create a greenhouse effect, and it wouldn't be possible to extract much of what is there with present technology. Establishing colonies beyond Mars. Asteroids, those rocky objects that orbit the Sun in a wide band between Mars and Jupiter, could serve as stepping stones to the outer planets. There are only 100 asteroids larger than 125 miles, 200 kilometers across. But a billion or more may exist, making them one of the solar system's greatest resources. But colonizing an asteroid would be even more challenging than building a base on Mars or the Moon. Asteroids don't have much gravity, so astronauts would face serious health problems from living in that environment unless they created artificial gravity inside the base, possibly by continually spinning the entire habitat. Because the asteroid belt is so far from the Sun, solar arrays that powered such machinery would have to be gigantic. There also would be the problem of shielding the colonists from cosmic radiation. You might think that tunneling into the surface might provide some protection, but doing that would be tricky, because a lot of the objects that we call asteroids aren't actually solid rock, but basically bunches of space junk without much structural integrity. But if we were going to colonize a smaller distant object, the dwarf planet Ceres, the largest object in the asteroid belt and the only dwarf planet in the inner solar system, might have some possibilities. NASA's Dawn probe discovered that the asteroid has an outer shell that's rich in water, in the form of ice and hydrates. The Obama administration had an ambitious plan, the Asteroid Redirect Mission, which called for capturing part of an asteroid and bringing it back to the vicinity of the Moon so that astronauts could land on it and retrieve samples. But the project was canceled in 2017 by the Trump administration. Heading for a planet in another star system. If we're going to colonize a planet in another star system, we have to answer two questions. First, do any Earth-like planets even exist outside of our solar system? Thanks to NASA's Kepler telescope, the answer to this question is yes. Kepler, which was decommissioned in 2018, located nearly 2,700 planets, what astronomers call exoplanets, orbiting stars anywhere from a few hundred to a few thousand light-years away. Many of the exoplanets are gas giants similar to Jupiter and Saturn, but others are super-Earths, rocky planets slightly bigger than ours. Some of those might possibly have the right conditions to be hospitable to human colonists. The second question is purely logistical. How do we get to a planet located trillions of miles from our own? To answer this question, scientists will have to rethink space travel. For example, the idea that a single crew will fly to a remote planet is highly unlikely. Instead, spacecraft might need to carry family groups capable of living in space for generations. Scientists will also have to come up with better propulsion systems to cut the travel time. Nuclear fission and fusion-based engines might be feasible, but more likely candidates include solar sails, ion propulsion systems, or antimatter rockets. Light sails work by directing laser light onto a huge aluminum foil sail. As photons strike the sail, they transfer momentum and push the sail forward. Ion propulsion systems use solar panels to generate electric fields that accelerate charged atoms of xenon. Such an engine powered the Dawn mission, which hurled an unmanned spacecraft to 2 asteroids, Vesta and Ceres, before its mission was completed in November 2018. Antimatter rockets are the most efficient and achieve the highest speeds, but the technology is relatively untested. Such a rocket mixes equal amounts of anti-hydrogen and hydrogen, which annihilate each other in a combustion chamber to release enormous amounts of energy. In the end, a combination of technologies may be the solution, proving once again that conquering deep space will require cooperation and collaboration among scientists of different disciplines and nationalities.